So here's a word problem. 10-foot ladder is slipping down a wall at a rate of, rate of 0.1 feet per second. How fast is the base moving? It's a related rate because it's give me a rate, ask me a rate. So let's draw this picture here. There's the ladder, there's the wall, there's the floor. It's a right angle. I'm going to call the distance y from the tip of the ladder to the floor, and I'm going to call the distance x from the base of the ladder to the wall. And so this would be the hypotenuse, or let's call it the hypotenuse because it's a right angle triangle. We'll be using Pythagorean theorem here. So x squared plus y squared equals h squared, Pythagorean theorem, we know that. All right, let's collect our information. It's give me a rate, ask me a rate. So the ladder is slipping down at a rate of 0.1 feet per second. So the y is changing with respect to time, this distance. It's slipping, it's negative, that distance is shrinking, negative 0.1 feet per second. Give me a rate, ask me a rate. They're asking me the dx dt is equal to what? Now, when I differentiate, now I need the equation that relates the x and the y. I've got that x squared plus y squared equals h squared. Now what I could do is I know the ladder is always 10 feet long. So I could just make this h squared 100 and then differentiate it. I could do that. What I'm going to do instead, just to make a point, is I'm going to say that I know that dh dt is 0 because the length of the ladder is not changing. Now I'm going to take this, it'll amount to the same thing. I'm going to take this equation and I'm differentiating it with respect to time. So everything's a function of time. X is a function of time, y is a function of time. So that'll be 2x dx dt plus 2y dy dt is equal to 2h dh dt. So I differentiated everything with respect to time. Now when I make dh dt equal to 0, this whole piece disappears. If I would have ahead of time made that h equal to 10, and then this whole right hand side would have been 100, and then when I differentiated that constant 100, it would have got to be 0 anyway. So different ways to get there. So it's give me a rate, ask me a rate. So I'm looking for this dx dt. I have this dy dt. Let's cancel the 2's off all three sides. So now I've got x dx dt plus y dy dt is equal to 0. How fast is it? When the top is 3 feet, so y is equal to 3. I just need, so this y is equal to 3, I just need to know what this x is. Here's where I'm going to use Pythagorean theorem. So if x squared plus y squared is equal to 10 squared, then x squared is equal to 91. So x is equal to the square root of 91. Plus or minus, yeah, but it's the length of a ladder, so I'm going to go with plus. So now I have the x, I have the y, I can sub everything into here. So root 91 dx dt, that's what I'm looking for, dx dt, plus y dy dt equals 0. Now let's solve this equation for dx dt. So this minus 0.3 is going to go to the other side. So it becomes a plus 0.3 divided by the square root of 91 equals dx dt. And I guess units would be in x is measured in feet and time is measured in seconds. So 0.3 divided by root 91, whatever that is on a calculator, feet per second. It's positive. Yeah, that makes sense to me because if the top is falling, the bottom is going out, the x is increasing. I expected a positive rate of change.